Hi, I'm Lars. Welcome back to the C# workshop. In this video, I'm going to review the mechanisms of the three iterators that we've talked about, the for, the while, and the do while, and then we're going to get into the for each statement and what the differences are between the for each and the traditional iterators. We're also going to talk a little bit about generics, and we're going to talk about the main collections that are used inside of coding today. So let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. For this video, we're going to continue on console apps. Project name's day 14, and we are not checking do not use top level statements. So we're just going to come in and we're going to add a new class, and I'm just going to call it worker because that's usually what I do. And this could be in another DLL, it doesn't matter. Typically they are in other DLLs, and the reason for that is because then you could take that other DLL and hand it to someone else, say all my stuff's here, all you need to do is say worker execute or whatever your standard is. So for right now, we're going to put in here our worker, and I'm going to call it execute because I usually do. And that's it. Over here we can create a worker, this worker is equal to new, and just say worker dot execute, and then I am out of the program file entirely. The using day 14 is great because there's a namespace. I don't know what the namespace is on the other side. We're going to go to the project itself, day 14, and we're going to make this disabled. And the main reason is because it tells you to null. It throws up warnings to tell you to null the reference types, which to me is annoying. I don't think I need to be putting question marks after a reference type. If you know about object-oriented programming, I don't know why they're doing that. Maybe it's a code generation thing, it's an AI thing, I have no idea. And it's probably more of an AI thing than a human thing, so I just don't use it. Implicit usings, I also get rid of that. The main reason behind it is because I want to see my using statements. I want to know where my stuff is. Like this here, console write line, using system should be here. Console is part of system. And the more that you know about the language that you're working in, the better off you will be. So the first thing we're going to do is we're going to have a quick review on iterators. So those are your for, your while, your do while, and your for each, and we're going to get into the for each. The reason that I did not talk about for each is because for each is quite limiting when you're talking about looping. A lot of people don't understand that. So a quick review for iterators, and that would be your for, while, do, while loops. Each of these loops have an initializer, they have an exit conditional, and they have an incrementer or a decrementer. And that means that you can go anywhere inside of that list or collection that you have. So say if you have 10 items in the collection and you only want to see 5, 6, and 7, you can do that without creating a new collection, without filtering on it, without doing anything. Then there is the for each. It iterates over each of the items for the entire collection. So it does not have an initializer, it does not have an exit conditional or an incrementer or a decrementer. But like other loops, it can use continue to skip over an item, like to go to the next item, and it can use break to get out of to exit out of the loop. So let's just throw a couple examples down here, and let's just see what the differences are. Let's just put a for loop in here with a normal iterator, and then we're going to put one that has a continue in and one that has a break when the I is equal to 2. So we're going to iterate over an array. And we're just going to use an array for this right now, but I promise we'll get into other collections during this video. So I'm going to hit F5. I'm going to dock the output window on the right side. And with this docked over here, you can see more of what's going on. So the for loop, if we iterate down all the way through this, you're just going to see 0 through 9. Because I'm using a write, not a write line. They're all staying on the same line. This one, when we get to I equal to 2, as you can see, they're all printing. There's 1. Now I equals 2, and we're going to come into this into the conditional, and we're just going to put a blank, and then we're going to continue, which is going to bring us right up to the iterator or decrementer right here. And then we're going to continue on. So we're going to skip 2, okay? That's what continue does, and go all the way to the end. And the break will do the same thing here, except for when we get to 2, we're going to break out of the loop, and it's going to be over, and that's it. So you can do this part with a for each statement. And if you do this with a for each statement, you're just going to drop numbers in here. So for I equal 1 to numbers, write out I. This is a lot simpler than this. Okay, it's a lot simpler to look at. The reason is because you don't need to deal with the numbers and the I. It's just going to iterate them all. Now, I don't know exactly why this was brought into play. I don't know why someone said, hey, let's do this for each. Maybe there was a study that said most of the time you're going through all the numbers and you can still use these in case you're not. Whatever it was. Most people have issues when you're doing things, and you notice this when you're in college or if you're taking classes with anybody. If this is 2 and you only want to print out the next 3. Okay? So people start having issues with this because they're like, well, I want to start at 2 and I only want to print out the next 3. So is this less than 5? Is it less than or equal to 4? And people do this. So this would be right. Both of these would be right. Less than or equal to 4 or less than 5. You don't have that option with the for each. So I'm going to get rid of all this. And you're going to see how a for each works. And you'll see the same thing that you'll see up here. You'll see this 0 through 9. Boom. 0 through 9. So we can do the same thing that we did with the continue and the break just by dropping these in. And they will run the same. I'm just going to run them through because it really isn't worth stepping through them. You can see that they do the same thing. So the concept is, if you come up to a number, you want to continue, you want to skip it, whatever. It could be a record. It could be anything. All right. Now, one thing about a for loop that 90% of the people do is they'll throw a var in here. And this is a variant. It's not a variant, but it's basically the code will find out what type of data type it needs to be. So these become pretty popular. I mainly use them in forech's, and I will use them when dealing with anonymous types. And we'll get into all that later when we're talking about entity framework and you're bringing back a large data set of multiple things that are coming back. The vars make life a lot easier.
Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime.
So one thing is, I'm going to pull these 2 off of here. Well, actually, I'm just going to comment them out. One thing is, since the for loop iterates the entire list, there is, like, say you only wanted to bring the 4, 5, and 6 out of here. Okay. So you need to create another list, another collection. There is something called a list. Literally, it's called list. It's a generic list, and it can be list event. And we're just going to nickname this guy list here. I'm going to actually drop this down to the bottom. And if you were only wanting to iterate, you didn't want to put blank spaces in like we did over here with the 2, you just wanted to iterate through these things. You could take list and say list is equal to numbers dot where, because it's a collection, this is a collection, you can do this. And then there's something called a Lambda operator, which is an equal sign and a greater than sign. Looks like that. So X is just any variable. You could put it in here, cow. It doesn't really matter what you put in. Most people use X, they might use Y. If you get really specific like this, if you start putting things in here like number, you're going to be hurting later, okay? Because you're going to copy these from one location to another. You'll notice in my coding, as we get down through coding, I will use things like list and item. Make them as generic as you can. I know all through the time that if you are a coder, or if you've been to school, or if you haven't been to school and you've been reading a lot of books, they tell you be as specific as you can. You don't want to do that, because when you start copying code and moving it someplace else to use it, now you've got all these variables that are strange and they don't make a lot of sense, and you're trying to find words to fit them in. So just skip over all that, okay? Now, say I want just the numbers that are greater than 3. Okay, so I can say where x is greater than 3. And that would give me 4, 5, 6, 7, 8, 9. And we could stop here and say dot to list, because we're going to transfer this to a list. So we're instantiating, we're building it. It's an IEnumerable, and we're going to bring it into a list. Now, all I need to do here is drop this down and just put list here. And like I said, I'm going to change this to item because it's an item in a list. Item. And we'll get into more complex things, but let me run this. So there you go. 4, 5, 6, 7, 8, 9. Like I said, we're not going to put a bunch of spacing in the front of it. Now, say, I remember I said, well, we only want 4, 5, 6. So you can say where x is greater than 3, or now that we're going to something else, say x is less, 3 is less than x, and x is less than 7. Or you could less than or equal to 6. Or you could say 4 is less than or equal to x and x is less than or equal to 6. Any way about you want. You can put any type of conditional in here that you want based on whatever this type is. And we'll get into more complex types here soon. Don't worry. So if we run this one, it breaks down 4, 5, 6. All right. Say you only wanted the even numbers, which you could have done that up here too. You could put this in here also. You could say where x mod 2 is equal to 0. 0, 2, 4, 6, 8. You could also come in here and say and x is greater than 0. 2, 4, 6, 8. So it's very powerful. This is a lot less code that you would need to do here than if you had to put all this into a for loop, just a regular for loop. And you could do this with a for loop too. I mean, real quick, I'm just going to mention this is a Lambda statement. It can be used on any type of collection. It's a library of functions, and they can be used to get information out of collections in memory. You also have a way to get them out using Entity Framework out of collections in databases, any database. There is another faction which is LINQ, and I'm going to show you this here. This is the Lambda version at the bottom, right here. So you take a list of animals, and then you want a list of animals to start with the letter B. You just say list of animals.find all, where A starts with B, and then you can use it and you're on your way. This does the exact same thing. This is LINQ, and here's your list of animals. This is looks like to most people as reverse SQL statement. So if you know TSQL, this is pretty much TSQL, but again, it is flipped upside down. Most shops use Lambda, and I know I'm going to get a lot of points in the comments for people saying, no, my shop uses LINQ, and you're not a common shop if you're using LINQ. There's no problems. I'm not biased on either way. I've worked in shops that use Lambda. I've worked in shops that use LINQ. I will tell you, using LINQ, there was a lot more issues with trying to figure out how to do something than there was with Lambda. And Lambda can do some pretty complex stuff. So enough of that. We're just going to keep on moving down here. Everything I'm going to do in this video will be in Lambda. Most videos will be in Lambda, but I will have a deep dive in LINQ and in Lambda, and then you'll see more about how they work. But one thing I will tell you, the time of iterating through a list to remove things or to only pull certain things out is long gone. If you're not doing something with LINQ or Lambda before you start displaying something or processing it or anything to that effect where you can filter out your stuff, you're going to be left behind. So this is the future. I don't think I've written one application except for in demos like the last few videos where I haven't done a Lambda statement. Now, as I said, we're going to get into something that's a little more complex. So the first thing we're going to do here is we're going to come in and we're going to say add a new class, and we're going to call it person. Because Person's really easy to deal with. I'm going to make this guy public. So inside of the person class, we're going to make it public, and then we're just going to drop in an ID, first name, and last name, and we're going to default these to empty. Nothing really difficult. We're going to comment all this out. And down here at the bottom, we're gonna drop in this list of persons, and we're just gonna create the list and use an object initializer to drop everything in. We could have used an add statement. We could have just put a semicolon here and then just put a bunch of adds for these guys, but this is easier. A list you can add to, subtract from, you can do whatever you want with it. That's why it's become the predominant collection used today in programming, and all languages use it. Say we want to just grab a for each statement here. And we say for each, and we say var, item in persons. So some people might say here person in persons. So say we just want to write out, the person's, you say person, and then you have total access to it. So we just putting out first name. So you will see Lars, David, and Nicholas appear in lines right above each other. All right, so there's your Lars, David, Nicholas that's been displayed. Again, now with persons, we could easily say persons. We could easily create a list for this here too and say we want another list of person. Call it list, where we say persons dot where, and say we just want everyone whose last name starts with a T. So we say X and put that in. Last name start with T to list. And if we run that, we take the list and drop it in here. And you get Lars and Nicholas because our names end in T. Now, you can take this, and instead of creating a new list, you could just put persons here and say where, put it right into the for loop. This does not affect who persons is. Okay, so if we come in and we put another for loop right below this and put this code in there, you will see it'll say Lars Nicholas and then Lars David Nicholas. So you're actually creating something and pushing it into the for loop. This is a standard. You will see this everywhere. Now, again, you can put anything in here you want. It's any type of conditional. I'm just showing some examples. So now if we go back over here to person, and there is a standard that's out there for displaying. So like you might put a default in here for display, and it may have, return. You could put anything in here you want. You put, first name, you put in here first name, space, last name, like that. And instead of doing a person here, I'm just going to get rid of this one. Say we come in and we put just person dot display. All right. And it is a method, so you need the method pipes. So you get Lars Thurman and Nicholas Tesla. Now, the reason that people do this is it makes it easy for someone to come in and just easily change this around, and the external code does not get edited. This is encapsulation. So you're encapsulating the way you want to display this. Now you could make this virtual if you wanted to. This way someone could inherit from your person and make their own person, and they could override virtual. Or they could override display. Or if they want to just override it and hide yours, they would put the word new in. All right, for anything that they're using. Since Lambda expressions have come about, some people are starting to use these. These are called expression bodies, but I like them a lot because you can put in here string name, put an arrow in here, and you can just pick this up and drop it in, and then you don't need this anymore. So this is what some people call an anonymous method. There's a variety of words for them, terms, but they're basically called expression body definitions. And then over here in worker, you would just say name. There's no method to call. So if you run this, you will see you'll get Thurman, Lars, and Tesla, Nicholas. So we go back to person, and I put a breakpoint here, and then rerun it. We are picking up Thurman. We are picking up first name. So these have already been set. Okay, and it works just like this. You can debug this. You can go through it and do whatever you want. In order to talk about this next collection, we need to introduce you to a key value pair. Now, key value pair is something that has a generics in it, and they can be anything. There's a key and there's a value. So, for instance, if we have int here and we have a string, then a key value pair could be new key value pair of int and string, and you could put in here a 1 and a string, like Lars. Now, why would this be beneficial? Well, there's a lot of times where you have an ID and you might have something. It doesn't have to be a string. It could be a person. You could put an object in here. I don't highly recommend putting an object for the key itself. It's just really hard to sort through them and figure out which one you want. Now you could put over here persons at 0.id, and then you could just put persons 0, and that would be a person. If you looked at key value pair, if I put a break here and we run this down to here, we're just going to hit F10 to step over it, and then you're going to see the key value pair has a key of 1, and then it has a value of person, and then you can see everything about me in here. Okay, everything that's up here is now in this key value pair. Now, why is this a good thing to do? It all comes down to something called a dictionary. If you take a dictionary and you say int and you put person in it, a dictionary is a key value list, if you will. That's the way I look at them. I look at them as a list of key value pairs. So if we put in here dictionary is equal to new dictionary, like that, again, it's a generic collection. So it's under system collections generic. So you can add to it and subtract to it as you want. So if we take dictionary dot add, now it's going to take a key and a person, and that's pretty much it. All right, so we can pick this guy up here like that, and we can drop it in. So let's put a breakpoint here. We're going to run this down, and you will see dictionary now has a key and a value. So here's a key and value, right? Just like the key value pair, you're just one layer up. Okay, so the dictionary has, this is item 1, key value pair. And that the item 1 here is because it's the key. So now let's try to add another one in. And we're just going to add the exact same thing. Well, you can't do that because the key has to be unique. Remember, this is a dictionary. So think of a dictionary just like you think of any dictionary. Will you ever find the same word in it twice? Right. So that's the reason why. So if we make this back to 1, you want to keep these together. Don't, go flipping them out. But if you go to 1 here, and you look at dictionary, you'll see the dictionary has a number 2 in it because that's the key. All right. It's not the indexer, it's the key to 1. So if you wanted to access something, you could very easily come in, say dictionary, and persons, whatever, 1, 0, .id. So we could write that out. Console dot writeline ID dot, and you're going to get the value after that. This will be the value. You don't have to put value in. You just say dot and get your information. So these are very powerful. These are used quite a bit. Let's run this. It's going to grab ID 1 and print Lawrence Thurman because that's what is an ID 1. It's not position 1. It's ID 1. Okay, so that's what's an ID 1 for dictionary. Lars Thurman, right there. If you look at ID 2, you're going to see Dave Gibson. So you could always come in here and say, make this a 1, pull this back up, right? So you'd have to say what? Person's 0 ID, right? So this would be person's 1, and you get David Gibson. So that's how dictionaries work. And again, lists, dictionaries, they're the most popular things in all of the world of C# and just programming in general. I will put this link below just to make sure everybody has it. But these are all of the generic collections that you can have. If you go to systems generic here, this is the basis of it. All right. And these are all of the collections that you can have. There's comparers, so you can do comparisons between two things. There's the dictionary. Here's your key value pair. Here's your list. There is a linked list. This is a doubly linked list. If you ever dealt with linked lists when you were in college, if you took any college classes, these are very important. Here's a linked list node. I will definitely have an entire deep dive on linked lists. These are crucial to the world of programming. There's ordered dictionaries. There is queues. There are stacks, sorted dictionaries. Then there's a whole bunch of structs too that you can use. Interfaces. So there's a lot of stuff that is out here. So make sure that you go through and you look at the collections, because these are something that you will spend a lot of time in. But again, like I said, it'll be in the description below. One last thing I'd like to talk about is how do you dynamically add stuff to a dictionary? So we could come down this path here and say for var, I'm just going to use person and persons like this. And we're going to get rid of this here. So we're just going to transfer everything from persons into dictionary. So you're going to say dictionary.add, and just like we did before, we're going to say the person, right? I'm going to say person.id, and then comma person. And that will add all of them to the dictionary. And then iterating a dictionary is a little different than just printing them out. So you're going to say var item in dictionary. See how item works really well? Instead of trying to figure out, well, what am I going to say? It's just item. And you can say console.writeline item dot, well, where's all the stuff, right? It's not keys. It's going to be item.value, and at that point in time, everything will be available to you for the person. So you could just put name in here like this. And then when you run this, you will see there is all three of these are put in. Thurman Lars, Gibson David, and Tesla Nicholas.
Thanks for watching the video. Please like and subscribe to the channel. I really hope you enjoyed the video, and now I hope you know why I held back on the for each statement until you could see the full picture of the collections. It's sad to say, but there's a lot of developers that do not know much about the first three iteration statements. They don't really teach them anymore. They get through them really quick because they want to, here's a for each is what people are using. There is a vast amount of other collections that I went over today. Okay, there's not only the list and the dictionary, those are the most popular, but there's a whole bunch of them. Check the links below in the description to learn more about other collections before you start creating your own. All right, there's a lot of people that will go and create a bit array when they've already got one, or they might create something like the string builder. They already got one. So just look into stuff before you start building something new, because it might have already been perfected. You're always welcome here in the C# workshop, and have a nice day.